Hello, today we'll be going over Codeforces Round number 640 Division 4, Problem F Binary String Reconstruction. So the problem statement is for some binary string S, all pairs of consecutive characters are written. In other words, all substrings of length 2 were written. For each pair, the number of ones in it was calculated. You are given three numbers, n0, the number of such pairs of consecutive characters, where the number of ones equals 0, n1, where the number of consecutive characters is 1, and n2, where the number of consecutive characters equals 2. For example, in the string s is equal to 11100111110, we can see that there is one instance where there is a substring of size 2 where there is two zeros, meaning that n0 is equal to 1. Here we can see that for the n1s, we have three instances where there is either a 1 0 or a 0 1. And then for n2 is equal to 5, we can see that there is 1, 2, 3, 4, 5 instances. We'll move on to how we can solve this problem, or how we want to create a string. So in the problem, we're giving n0 is equal to 1, n1 is equal to 3, and n2 is equal to 5. So what we can do is we can start from the center and branch the string off to the sides. So given n0 is equal to 1, we can start out with a 0 and another 0. And the reason why we have two zeros is because it takes two zeros to make the first subset of size 2, and then adding another 0 will give you another one, and another one, and another one, so on. But to create the first subset of 2, it takes two zeros. So therefore, for the center, we would have n0 plus 1 zeros. Now let's move on to the sides. How do we want to calculate n1? Well, what we want to do is that we want to essentially surround it, what we have currently, with ones. So that way, we can branch off with our ones on the right side, and we can create our zeros and ones for n1 on the left side. So let's go over this more in depth. So once we create our 1 on the right side, we want to subtract 1 from n1. So then we become 2. And for the remaining 2, we want to consecutively add 1s and 0s for n1 minus 1 times after we add this. Therefore, we will end up with 1, 2, 3, and 1s, the desired outcome which we want. Now let's move on to the n2s. The n2s should be fairly simple. All we have to do is we see on the right side that we already have a 1 over here. So we just have to add n2 ones on the right side. Let's go over three base cases when creating our string. The first case is if n0 is equal to 0 and n1 is equal to 0. In this case, we would have n2 is greater than 0. So in this case, we would only have subsets where there is two ones. So in this case, it'd be fairly simple. We would just have n2 plus 1 ones. Case number 2 is where n2 is equal to 0 and n1 is also equal to 0. This is very similar to the previous case. In this case, we would just have n0 plus 1 zeros. Case 3 is where n1 is equal to 1, n2 is equal to 0, and 0 is equal to 0. In this case, we see that we can just simply print out a 1, 0. These are three of the base cases which we can run before our actual string construction program. So aside from the base cases, let's start constructing something that does not fall under any of the base cases. So the first thing we want to start off with is the zeros. And as we've already seen, there should be n0 plus 1 zeros. But let's look at some examples where n0 is equal to 0. So let's look at 0, 1, 2, perhaps. In this case, what we want to actually do is we do not want to place a 0. Keep in mind that our formula asks for n0 plus 1 zeros. So in this case, there would be 1, 0. However, if we think about this logically, the way we would want to construct it is like this. We would start out by the 1 here, we would branch out to the left with the 0, and then we would branch out to the right with these 2 1s. This would be the ideal way to solve it. So therefore, we will not actually want a 0 to begin with. So therefore, we only want to create the amount of zeros if n0 is greater than 0. This is one thing to keep in mind. Second thing is, let's say we have something like 0, 2, 2. In this case, we would actually want to start with a 0, put a 1 on the left side, put a 1 on the right side, and 2 1s as shown. In this case, we actually start out with a 0, and then we build to the right and to the left of it, and then we place our 1s afterwards. In this case, we are starting with a 0. So therefore, we have to write this for 2 cases. Case 1, where n1 is odd. Case 2, where n1 is even. So we have to account for these 2 different cases. Now let's account for the case where n0 is greater than 0 and n1 is greater than 0. In this case, we can look back at the example which we had to start with. n0 equals 1, n1 equals 3, n2 equals 5. In this case, we are going to print out the amount of zeros because 1 is greater than 0. So that is our first case. Now we want to print out our 3's. So in order to do this, we're just simply going to print out a 1 here. This is going to be our first step in doing so. And then after this, we are going to print out a 1 and a 0 on the left-hand side. Now, how do we keep track of this? Well, what I did was I created 3 strings, 3 empty strings called S0, S1, and S2. So the center one would be marked as S0. The right side one would be marked as S2, and the left side one would be marked as S1. So now let's go over back to the original problem. So we've already started out with our 2 zeros. From here, on the right-hand side, we want to add a 1 to S2. So then, in this case, we have S0, 0 equal to 2 zeros. We have S2 equal to a 1, and S1 equal to nothing. Here what we want to do is that we want to start constructing the left side. So we're going to add a 1, a 0, a 1, a 0, and how many amount of 1s and 0s we need, which would be n1 1s and 0s, alternating. So there would be n1 over 2 1s and n1 over 2 0s. So then the left-hand side would end up looking like this. 1, 0, 1, 0, 1, 0, and so on. And then for the right-hand side, all we would have to do for n equals to 5 is just add n2 1s. And then that is easily how we construct it. So then we would just have our 1s like this for how many amount of 1s we need. But one thing which we want to keep in mind is if we do it this approach where S0 is greater than 1, let's look at S1 real quick. If we print this out as S1 plus S0 plus S2, we would end up with something like this. 1, 0, 1, 0, 1, 0. And then we would have S0, which would be 0, 0, and then the amount of 1s which we want. But over here, remember what we wanted. If we had 2 zeros in the center, we wanted it to surrounded by 1s. But over here in this case, we have an extra 0. So what we can essentially do to counter this is we can take our S0 string over here, and we can essentially just reverse it. So from 1, 0, 1, 0, 1, 0, and so on, it'll become 0, 1, 0, 1, 0, 1, 0, 1. So therefore, we would always have this 1, which would surround the 2 zeros which we want, and then we can have the appropriate amount of 1s on the right-hand side. Now let's go over the actual code implementation of the solution. So we're going to start out with our integer t, the number of test cases, and input into t. And then for each test case, we're going to have our three numbers, int n0, n1, and n2, and we're going to input into all three of those. From here, we can create our base string s equal to nothing, and we're just going to use this temporary string for our base cases. So our first base case was if n1 is equal to 0 and n2 is equal to 0. In this case, remember that we just want to print out the appropriate number of zeros. So in this case, we are just going to have a string of zeros, so we want to print out n0 zeros, which would just be s.push underscore back 0. And then we can just print out s from here. Or you can just directly print out the zeros. Second base case, we can just copy and paste this, but change n2 equal to 0. So basically, we would just have n2 is greater than 0. So we would just have a string of a bunch of ones. And we would have n2 plus 1 ones, which we can write in this for loop. And then the third base case was if n1 is equal to 1, and n2 is equal to 0, and n0 is equal to 0. In this case, we can just print out 1, 0, or you can put it into the string s, either way works, but we just want to print out a 1, 0, and then we're done. And we can change these to else if statements. Now let's move on to if it's not a base case. In this case, we could have our else statement. We can create our three strings, s0, s1, and s2. With these three strings, we first go into the first statement, where if n is greater than 0, we want to put into 0. Sorry, if n0 is greater than 0. Then from here, we're going to create our for loop. And we're going to input into it by s0.push underscore back a value of 0. Remember, as stated previously, we're going to have n0 zeros. Now after this, we want to check our n1 statement. So the first thing which we want to check is if n1 is greater than 0 and n0 is equal to 0, as we stated previously. In here, there are two smaller cases where if n1 mod 2 is equal to 0, basically if n1 is even, and if n1 is odd. Or we just write an else statement here. So if n1 is even, we want to create our for loop going through and pushing back alternates 1s and 0s. So what I've written here is that we have our for loop, which should go up to n1 plus 1 times. And if it is, so for each I, it's going to go 0, 1, 2, 3, 4. If it is even, I can just write I want to put a 1. If it is odd, I want to put a 0. This way it will alternate between odd and even, printing out 1s and 0s. For the second case, we can essentially copy and paste this. However, we want to start out with a 0 and end with the 1 instead. Now the next thing which we want to do is we want to create an else if statement, n1 is greater than 0. In this case, n0 can also be greater than 0. So in this case, remember, we want to add a 1 to s2 because we want to add 1 to the right side, and then we want to start with the 1s on the left side and go 1, 0, 1, 0 on the left side. And then from here, we can actually decrement n1 so that we know that we've already put a 1 on the right side, so now we only need to focus on the left side. So since we've already put 1 on the right side, we have 1 less to put on the left side. So from here, we can write down our for loop that will put down the appropriate number of 1s and 0s on the left side, and we can actually essentially copy this and paste it down here. And then we can also actually create another string called stemp and set this equal to 0 or nothing. And what this stemp string basically is remember we wanted to reverse the string after we created if and 0 is greater than 0. So what we're basically going to do is write a simple for loop for int I equal to s1.length minus 1, I is greater than or equal to 0, I minus minus. We are just going to copy stemp or copy s1 onto stemp in reverse order, and then we can just at the end add 1 to n1. So therefore we don't actually change the values which we have inputted. So from here, since we're going to use s1 in our actual answer, we can set s1 equal to stemp. And then since we don't want to change any of our original inputted values in case we need them later, we can add 1 to n1 as we have subtracted it beforehand over here. So from here, our next case is if n2 is greater than 0 and n1 is greater than 0. From here, we want to write a for loop that goes through, and we're going to write s2 push back once. So what this basically is say n1 is greater than 0, we know that we are going to start with a 1, then on the left side 0, 1, 0, 1, and on the right side we want to immediately start with a 1. And we're only going to do this n2 times because we start out with a 1, and then we want to just add n2 ones towards the right side. And then the second part of this is else if we just have n2 is greater than 0, then in this case, we are just going to write our for loop. This is in case, for example, if n0 is greater than 0. Then we would actually start off with a 0 in the center. So then we would create a 1 on the right side, but we would need to create an additional 1 on the right side as well. So keep in mind when printing this out, keep in mind the order S1, then S0, then S2. And then at the end, we can return 0. After running and building this code, we can see that this is accepted.